So, our science teacher set us a challenge, which was to obtain pure ethanol from red wine, which is 86% water and 14% alcohol. To do this, we used distillation. We first put 100 milliliters of red wine into a small conical flask and topped up the conical flask with a bung. We then took a large beaker and filled it with 150 milliliters of cold water before placing the conical flask into the beaker. A Bunsen burner was set up, connected to gas. We set up a tripod with a wire gauze on top of it, placed the beaker on the gauze mat, got out a retort stand, and set it up so that it held a thermometer, with its bulb in the water, not touching glass. The other side of the bun was placed in a boiling tube, hanging so that it did not touch the bottom. The boiling tube was placed in a large beaker, surrounded by ice cubes and some water. But why did we set it up this way? The answer is distillation. Distillation is based on the general idea of evaporation, but takes it a step further. The basic concept of evaporation is that a liquid gains sufficient energy to overcome their bonds and turns into a gas. Since water and alcohol have different boiling points, we plan to boil the alcohol so that it evaporates, leaving the water behind. The purpose of the bun is to direct the ethanol gas into the boiling tube. Since the boiling tube is quite cold, the gas will quickly lose heat and kinetic energy. This will cause the gas to no longer be able to overcome the attraction. It will form bonds and become liquid ethanol again. Now, the tricky part of the experiment is keeping the temperature right. Since we only want alcohol and not water in our final solution, we have to keep the wine's temperature between 78.37 degrees, alcohol's boiling point, and 100 degrees, water's boiling point. This is so that the alcohol turns into a gas and escapes the conical flask, but the water remains a liquid and thus remains. This is where the thermometer comes in. By constantly tracking the temperature of the outside water through the thermometer, we can control the temperature of the red wine. This enables us to know when the wine is getting too hot, and we can take measures such as adding ice cubes or turning off the Bunsen burner. To start with, we turn on the Bunsen burner before adjusting the flame so that it is blue. This is to heat up the wine faster, thus getting better results. The heat increases the temperature and kinetic energy of the liquid's particles, making them move faster and faster until the heat hits the boiling point, which as stated above is different for the water and the alcohol. At that point, the liquid stops using the kinetic energy to increase its temperature and vibration speed and starts using this to break bonds. This temperature is known as the boiling point. A similar process that uses the same principle is known as evaporation. However, there are some key differences between the two processes. Evaporation happens slower, only at the surface of a liquid, can occur any time, does not produce bubbles, and leads to cooling. This is because the particles with the most kinetic energy escapes, thus decreasing the average kinetic energy of the liquid. On the other hand, boiling occurs all throughout the liquid, is quicker, produces bubbles, and does not decrease the temperature of the liquid. While evaporation does not need heat energy, boiling relies on the continuous heating of the liquid. Back to the experiment. As you can see, the thermometer has reached 78 degrees. From here on, the alcohol has started to boil. As it boils, the alcohol gas will be funneled through the plastic tube, cooling down as it moves away from the heat source. This will cause the ethanol particles to move slower and slower until they enter the boiling tube. Condensation happens when a warmer gas comes into contact with a colder surface. With the ice cubes, the boiling tube qualifies as a colder surface. Since the temperature of the boiling tube is so low, the gas will quickly lose heat energy, thus rendering itself unable to overcome the attraction. This will cause it to reform bonds, becoming a liquid again. And with that, here is a drop.
Last, we set the alcohol we collected through distillation on fire. We didn't manage to get much, but what we did get was extremely pure. Thank you for watching. Good night.